This work presents a scalable and distributed collision avoidance scheme for multi-agent UAV systems. We use a distributed nonlinear model predictive control formulation, where the predicted trajectories are shared among agents in the system. To allow for the system to be scaled up and to reduce computational complexity, we developed an obstacle prioritization method based entirely on the motion intent of other agents. To solve the NMPC problem, we used the open source optimization software optimization engine, where an augmented Lagrangian method is used to compute collision-free trajectories. We validate the scheme in a laboratory environment in 3 different experiment scenarios. First, the task of the UAVs is to hold a formation while agents move one by one to fill the unoccupied slots. Because the motion intent is shared among agents, minimal disruption of the formation is required to complete the task. In the bottom right, you see a visualization of predicted trajectories. While the decision variable in the NMPC problem are roll, pitch, and thrust references for the UAV, we can use the nonlinear UAV model to predict future positions based on the computed trajectory. Note that at every sampling instant, the obstacle prioritization scheme decides which agents the eco agent should consider as obstacles. Next, 10 agents are set up as 2 teams of 5 will swap positions. This creates a very difficult obstacle avoidance scenario, where we require that no 2 agents should violate the specified safety distance. Let's observe the obstacle prioritization in real time. The eco agent is shown in blue, while prioritized obstacles are shown in red. The UAV dynamically changes which agents are considered as obstacles based on the shared trajectories in time to avoid collisions. We also introduce a non-cooperative obstacle to the system in the form of a manually controlled UAV. Since its motion intent is unknown, we will assume a linear prediction of its future positions based on an initial measurement of velocity and position. UAVs are tasked to hold a tight formation, while the manually controlled UAV tries to generally disrupt them. Here all agents must avoid the non-cooperative obstacle while also maintaining distance to each other. If there are any further questions, please do not hesitate to contact us, and I thank you for watching this video.